Hello class, this is a video tutorial on the composite functions and operations part 2. So after functions have been combined via the composition of functions, the resulting domain and range may be affected. This is especially if one or both have a restricted domain or range. So what we'll do here is we'll have three different functions, f, g, and h. And I'd like for you to pause it and give it a go. Find the domain and range for each of them. Make the composite function for each of them. And find the domain and range for the composite functions found in B. So I'd like for you to pause the video and give that a go for now. Okay. Hopefully you've had a go. So let's answer these now. For the domain of f, well, that's just a linear function. That's nice and simple. Any value of x will give a real value of y. So the domain for a linear function is from negative infinity to positive infinity, or you can say just all real x. Same for the range. There doesn't seem to be any restriction. So if we were to draw this linear function, it would it would just be a line like so. So it goes off to positive and negative infinity. So from negative infinity to positive infinity. So that's for the f. As for g, same question applies. What value of x are we not allowed to put in? Well, for this, there's no restrictions on a parabola. So any value of x that we put in will give us a real value for y. So the domain for this is the same. All real x. As for its range, we should always consider the graph itself. So since it's a parabola, it would be sitting, well, the regular parabola, it would be sitting on the x-axis like so. Oops. I think you get the idea, where the lowest value here is going to be 0, 0. So its range starts from 0, but goes off to positive infinity. So that's the range for the parabola. As for h now, since it's the square root of x, the values that cannot be in here are negative values. That must mean its domain, the lowest value that can go into square root x is 0. So it begins on 0 and goes to positive infinity. And for its range, the graph of this looks like it's flattening out, but it continuously increases, even though the rate of its increasing is reduced. So its range starts on 0 and goes to positive infinity as well. So that's the domain and range for each of the functions. For its composition of these functions, for this we need to take the function of f. So here's x plus 1, because that's what the function is, x plus 1. And where x is, we're going to substitute g. So our net function, or the resulting function, is x squared plus 1. If we were to switch this around, g is x squared, so there's x squared. And inside of that, we're going to substitute f in there. So it's going to become x plus 1. For g of h of x, once again, g is x squared. And inside of that, we're going to substitute h of x. Well, these two cancel. The square root of x squared just becomes x. And even if we were to switch this around, because now it's h of x, so h of x is square root, and inside of h of x, we're going to substitute x squared. So, like so. That also, and this also, this also gives us a net result of x. But now, let's stop and think about the domain and range for each of these composite functions. For this one, that is just now a parabola that's been moved up like so. So its domain hasn't changed. It's still, it's still from negative infinity to positive infinity. But its range now has been shifted up. So its range begins at 1 and goes to positive infinity. As for, actually we can keep this. As for this function, that is just a parabola. So there's the regular parabola. The plus 1 shifts the function to the left by 1. So its range is still from 0 to positive infinity. And its domain is exactly the same. There's no restriction on what x values we are allowed to substitute. Now, here is where it gets a little tricky. I want to see if you can think about what the domain and range are for these two functions. If you had said that since this is just a line, y is equal to x, you would think that the domain is negative infinity to positive infinity, so all real x. However, what we need to think about is that even though this is the resulting function, we must always begin on the inner function first. What this means is, sure, y is equal to x, you can substitute negative numbers here. However, this is resulted from square root x first. So before we can even substitute into x, we actually need to substitute here first. So if we wanted to substitute x is equal to negative 1, we couldn't just substitute it here because the function begins in h. So that means we have to substitute into here first, take the result, and then substitute into g. That's what this implies. H first, and that result gives us g. Well, as you can see from here, h of x has a restricted domain from 0 to infinity. Since we have that, the domain of this function, since it starts with h, is also from 0 to infinity. As for its range, well, if we think about it again, even though this looks like it can reach negative y values, the only way we could get negative y values is if we substitute negative values here. But, as you can see, that's impossible. So the range for this is also from 0 to positive infinity. You'll find it that the composite function will often, not always, match the most restrictive domain and range in that chain of functions. So since h is the most restrictive, it's often the case, but not always, that the composite function has to follow the most restrictive domain and range in that chain of functions. So here's another one. In this, we're starting on g and then taking the result and substituting to h. Now, let's think about this. If we wanted to substitute x equals negative 1, we could substitute it into g. That's allowed. And then whatever result we get, we substitute that result into h. Well, even though the net result is the same for both, g, its domain and range, well, its domain at least, is from negative infinity to positive infinity. So in this instance, we actually can substitute negative values and positive values. But its range, even for the parabola, okay, even though it's a parabola, the results from here are always substituted into square root x. So for example, if we were to substitute x equals -1, we substitute that into g, we get 1. Substituting 1 into h, we still get 1. If we were to substitute 0, we would get 0. Substituting that into square root x would give us 0. So, as we can see from here, the range begins from 0 and goes to positive infinity as well. So I hope that gave you an insight into the domain and range of composite functions. Hope to see you in the next video. Best of luck.